Hi, good afternoon, good morning, good evening, wherever you are. Thank you for joining the webinar, What's New in SolidCAM 2020. People are still joining us, so let's wait for another 3 to 4 minutes before we start the webinar. Thank you very much. Everyone, welcome to this webinar, What's New in SolidCAM 2020. This webinar will be handled by our product manager, Mr. Ashok Kumar. Ashok comes in with years of experience working with different CAM products, and he has been a product manager since the last 7 to 8 years now. Ashok lives in Bangalore, and this webinar will be completely handled by him. Although this webinar is what's new about SolidCAM 2020, there are some features of 2019 that will overlap into 2020. So we would also like to touch upon those features of 2019 into 2020. I hope you enjoy this webinar. This webinar is going to be approximately for 90 minutes. And I'm going to make Ashok the presenter now. Ashok, you're the presenter, and you can start.
Thank you very much, Pramod. Okay, my voice is clear?
Absolutely. Please show your screen and you can start.
Yes. So, right. So you're able to see my screen now, presentation screen?
Yes, we can. Please go ahead.
Okay, thank you. Okay, good morning, everybody. Good morning, good afternoon. Thanks for a very nice introduction, Amod. My name is Ashok Kumar. As you mentioned, I am working as product manager with SolidCAM India since 2010. Today, I'm going to present what's new in SolidCAM. As he mentioned, I would like to touch upon some of the new enhancements or new features which are available in SolidCAM 2019 SP1 and also 2020. So what I have planned is the entire presentation I have split into 5 different categories where we will see what are the enhancements or new features available in general category, in 2.5D milling, iMachining 2D, iMachining 3D, HSR, HSM, HSS, and the new simulation engine what we have introduced in SolidCAM. So apart from all these new enhancements, we have also done major enhancements in our advanced Milton module and also Swiss type module. So today I'm going to cover only these 5 different categories. So let me start with the presentation, and I'm going to show you the presentation for some time. Then we will switch over to the product. We will see the new same functions inside the product, and then again we'll switch over to presentation, and again we will see the features inside the product. Right. So as I mentioned, first let's go ahead with the general enhancement what we have done in 2019 SP1 and 2020. The moment when you open any SolidWorks part file or an assembly file, SolidCAM is already loaded inside SolidWorks UI. So you can see SolidCAM is already opened inside the SolidWorks environment. If you don't want, you can disable this inside the SolidCAM setting. So the moment you open any SolidWorks part file or an assembly file, so you can see the SolidCAM which is already running inside SolidWorks environment. The second important general enhancement what we have done is we have SolidCAM task pane. Instead of every time going to tools, SolidCAM, new CAM manager, or open recent part, instead of doing all these setups or all these steps one by one, now we have this SolidCAM task pane. Right hand side you'll get the SolidCAM task pane. You can create a new CAM project. You can open any existing CAM project. You can create a new tool library. You can do all SolidCAM settings. You can browse recent CAM parts. Everything can be done using this SolidCAM task pane, which is available on the right hand side of the GUI. Another new function which is available is now you have a SolidCAM tool in the toolbar. You have inside the feature manager. So you can also do the similar kind of activity, like you can create a new CAM part. You can open a CAM part. You can open a recent CAM part, you can save the CAM part, you can do CAM part setting for this particular project. Everything can be done using this SolidCAM toolbar, which is available inside the feature manager. We have also introduced a new function called updated stock function. So this is again available inside the CAM tree. Under target, you can see this updated stock function. Suppose if you want to see the updated stock condition, you can switch on this particular function and you can just drag this feature and drop it on the particular technology or the strategy where exactly you want to see the updated stock condition. The moment you drag and drop this icon, immediately it will show the updated stock condition in the graphics area. We can see this updated stock condition without going into the actual simulation. So, and also another very important thing is once you drag and drop this icon and see the updated stock condition, you can always save this updated stock file as an STL file, and you can import this STL file as a initial stock file for any other setup or any other CAM project. So this is the same thing. You can just select the updated stock icon in the CAM tree, and you can just drag and drop it exactly on the strategy or the toolpath where exactly you want to see the updated stock condition. Immediately it shows the preview in the graphics area. Now you can also customize your HSR, HSM menus. Generally, when you go to HSM technology, you will find about 20 different kinds of strategies which are available under our HSM module. If somebody wants to see only the most used option, you can always customize the menu. So you can choose which are the most common used strategies. So you can customize so that the user, you can customize the menu and it will simplify the GUI. You will find only the most used strategies inside the pull down menu. The next very important feature or functions what we have introduced is a drag and drop template. So this is a very powerful and most advanced function, which is a drag and drop template. So you can create your own template, operate like operation template or process template. So you can create operation templates for all kinds of strategies like 2.5D milling, whether you're doing facing, drilling, pocketing, profiling, or you're doing iMachining 2D or iMachining 3D, HSR, HSM, or HSS operations, as well as even the pocket recognition or chamfer recognition operations can be saved as operation template, and that can be saved inside this operation templates folders inside the SolidCAM task pen. So you can always just drag and drop it on the geometry itself, or you can just drag and drop it in the CAM tree. It generates the toolpath irrespective of whatever geometry you are selecting. So automatically it generates the toolpath. This is very powerful tool. Believe me, you can reduce a lot of time for toolpath calculation. Whenever you want to do cycle time estimation, whenever you want to do RFQs, this will help you to a very large extent. So you can use these templates even for operations and also for the entire process. So you can apply for the entire process, including the whole wizard process can be used in with this drag and drop template option. Now you also have full control of part and fixture inside the setup. So when you click on machine setup, you have now it will allow you to set the absolute value as on the machine for the part separately and for the fixture separately. So you can see this inside the machine setup. So you can set the values with respect to part position and also with respect to fixture position. Another new function is now under SolidCAM settings. When you go to SolidCAM settings under miscellaneous function, the temporary directory cleanup utility is available. So it cleanups the temporary files, or if the files are not closed properly, it shows them which are the CAM parts which are not closed properly or saved properly. You can clean up the temporary files so that it will be removed from the temporary directory inside SolidCAM setting. Another new function is if you are working on network environment, this is very useful for people who are working on a network environment. You have a 5-user profile or 10-user profile, and somebody is already using the CAM part and working on that. If another user wants to open the same file, now immediately it opens up a message, it opens a pop-up window, and gives the information on this particular network, this particular project, or the part file is already opened on what date, what time, who is using this particular project. It gives the information so that another user knows very exactly this particular file or the project is already being used by one more person, so he can just continue opening that or he can cancel that particular project. So this is very useful for people who are working on the network environment. So these are all the general enhancements. Let's switch over to the software and we will see the same functions. So now I've opened the SolidWorks 2020. So now when I say file, new part or assembly, when I create a new part on an assembly file, as I mentioned, the SolidCAM will be loaded automatically. So SolidCAM Manager is already loaded inside the SolidWorks GUI or SolidWorks environment. So this is one general enhancement function. The second function, let's open another part. Right, so now as I mentioned, you can see earlier we always used to go to tools, SolidCAM, new, start with new milling part or turning or mill turn, or go to recent parts. So all these things can be done from the task pane. So now if I click here from SolidCAM task pane, so you can create a new milling part or turning part or turn mill or mill turn part. You can open any existing CAM part. You can create a new tool library. You can do SolidCAM settings. You will get online help. Everything can, and also open recent CAM parts. Everything can be done using this SolidCAM task pane. Another function what we saw is the feature manager inside SolidCAM tree. So here you can see from SolidCAM tree also you can open any CAM part, you can create a new CAM part, you can save the CAM part, you can close the CAM part, and also you can do SolidCAM setting with respect to particular CAM project. So you can avoid so many steps instead of going to tools SolidCAM every time and opening the CAM project, editing the CAM project. Either you can use the SolidCAM task pane. From the task pane you can use the same function, or you can use the CAM tree where all these functions are available. Another general enhancement what we have done is I was talking about the updated stock. So you can see the updated stock function is available under target. So if I click on updated stock function, so immediately it is showing currently now it is the icon is placed on the first strategy. So it is showing the updated stock condition. This is the raw material after face milling. What would be the condition? Immediately it shows in the graphics area. So now suppose if I drag this to the next one, after facing, after pocketing, immediately it updates the stock condition. So you can keep dragging this. So it shows the updated stock condition in the graphics area. And also you can right click on this particular updated stock icon and you can save this stock file as an STL file, and you can use this STL file as an initial stock file for any other setup or any other CAM project. So another enhancement what we have done is customization of HSR HSM menus. So now you can customize here. Suppose if I remove all these things, so you will find about 20 different kinds of strategies. So if you don't want to see all of them, if you want to customize and you want to like to see only the most used strategies, you can select them. Let's say constant Z, linear machining, it's a rest machining, then parallel pencil milling, and then horizontal machining. That's it. So I'll just click and then just click on that menu. Now you're able to see only the 5 strategies which we have customized right now. So your GUI will become very clean, very easy for the user. He will see only the selected option under the pull down menu. Right, so this is another enhancement under general category. So now let's go ahead and see the most powerful function, that is drag and drop template. Let me open another CAM part. Right. So I'll just delete all the strategies. So now from the task pane, now you have this drag and drop template option here. So here from 2020, it is filtered and arranged very neatly. You will find each operation templates under different strategies. Like if you have done a face milling template, it is available under face. If you have done pocket template, it is available under pocket, profile, slot. Everything is very neatly arranged. So you can just select whatever template you want to apply. So now let's say I want to do face milling. So instead of creating the strategy, going to 2.5D face milling, selecting each and every parameter, you can just drag and drop that. Just a minute. Right, so I can, sorry, because this is in trouble. My GoToMeeting session window is covering the area. Okay, just let me move that. Okay, so now I'll go to this drag and drop templates. Let's say I want to do face milling. Under face milling, there is a standard template already available. I just select that and drag and drop it on the face. So immediately it generates the toolpath. So if I just edit this, so it has taken the updated boundary condition automatically. It has picked the tool from the previous process template what I've created. I selected the level automatically, technology, how much stock you want to keep. Everything is taken care from the template. So let's say I want to do this open pocket. Again, I can just go to drag and drop template. There is open pocket template. I can just drag and drop it on the face. So the moment I drag and drop it on the face, immediately it picks the geometry, it picks the boundary, generates the toolpath. So now if I go to simulation, so it has taken the same parameters from the previous template, immediately doing open pocket. So for example, now we would like to do this closed pocket. Again, I can just go to drag and drop template. There is a closed pocket template. So suppose if you want to apply for these two closed pocket, you can just select the template, press Control button 1, 2, just select them. Immediately it starts applying for both the pockets. So it has generated the toolpath for both the closed pocket. So if I open this, if I edit this strategy, so what all it has done, I've just dragged and dropped the strategy on the two faces. It has picked the geometry. So it has selected the geometry. It knows these are the geometrical boundaries. Then it has taken the tool, the 16 diameter tool, and the cutting parameters what I've used in the previous strategy. If I come to technology, it has taken the same wall offset, same floor offset, whatever we have kept in the previous template. And also, if I come to linking, it has taken the same helical ramping option what we have set for the closed pocket template. So like this, you can keep dragging and dropping the templates for all the kinds of strategies, whether you're doing simple 2.5D milling like facing or pocketing or profile or drilling. Even suppose, let's say you want to do drilling, again, I can just go to drag and drop template. There is a template already available for drilling with 6 mm drill. I'll just drag and drop it on this face. Right, it's already selected the faces. If I go to geometry, so it has picked all the holes. So only thing is I have to check only the drill diameter because the previous one with the 6 diameter. So I can just click on this face. I'll just go to evaluate and measure the whole diameter. I'll just pick the face diameter here. So it is about 13.5 diameter. Automatically SolidCAM will create a new drill of 13.5. Just select the drill. You need to just check the depth because here for drilling we are going to pick only the hole centers. So I need to just select the lower level. That's it. So it has already taken the technology, the drilling cycle, G83 cycle, and just save and calculate. So you can keep adding you can just drag and drop these kind of templates, whether you are doing simple 2.5D functions or HSR, HSM, HSS, 5-axis simultaneous. For all the strategies, this drag and drop template is available. And believe me,
Ashok,
this is
sorry
the
to interrupt you. Sorry to interrupt you. Could you also show how to create a template? You've already created a template, so just create a couple of templates quickly and show them.
Okay. So let's create one template. I'll just go to SolidCAM now. Let's say I would like to machine this open pocket again. I just go to 2.5D milling, pocket milling. So my geometry, again, we have this smart face function. I just pick the face. So it automatically selects the boundary. It marks the open edge. It's very intelligent. It marks the open edge. I'll just make the offset 0. I'll go to tool. I just select the tool from the library. I would like to use 20 diameter end mill. And you can give the cutting parameters here. Levels, okay, 2 millimeter depth of cut equal slip down. It has taken the depth automatically because we are using the smart face. So let's say I would like to 0.3 wall offset, 0 stock on the floor. Since it is an open pocket, I would like to approach from outside and link. I don't want to use anything. I just say save and hit on calculate. So I have created this strategy. Now I would like to save this as a template. So here there is an option, save template. So I can just give a name here. I can say 009. I'll say open pocket template, right? With 20 flat end mill, I can give the operation name and I can just save this template. So the moment you click on save button, so by default, this particular template will be saved in the default location, like goes to C users public document SolidCAM and SolidCAM 19 or 20, where this default this directory is set, it will save in that particular location. Also, you can change the location, you can create your own directory and you can save this template in your own directory. So now after giving the template name, you should use, if you want to include the tool data, just select by default, it is always set, it includes the tool data. So when you tick tool data, it picks the tool diameter, the cutting parameters, everything, and also geometry filter. I'll just say okay and exit. I'll just say save and exit. So now if I come to drag and drop template, now this particular template is already available here, 009 open pocket 20 flattened line. So I can just, again, if you want to generate for this open pocket, I just select this, drag and drop it on this face. So immediately it generates the toolpath. Now, if you see the previous template, I've used contour option. Now with the new template, I'm using the profile strategy. So the toolpath is just, it is always parallel to the boundary what we have selected. So you can create any template, okay, and you can be saved. So these templates can be either an operation template or the entire process can be selected and can be saved as a process template. You can create the entire process template. So here also you can give the process name. I will show this when we come to HSR, HSM. So you can create the entire process template, including the tool data and geometry filter, and save them. And you can use that for any model, irrespective of the geometry or irrespective of the setup, whether you want to use it in operation 10, operation 20, or operation 30, you can keep dragging and dropping the templates. So believe me, this is very powerful and very user friendly. It will reduce a lot of time for generating the toolpath. It reduces a lot of time for cycle time estimation. And if you want to do any RFQs, want to submit the cycle time quickly, you can have some templates readily available. Just keep dragging and dropping them, generate the toolpath. In few seconds or few minutes, you can generate the complete toolpath, generate the process sheet, and you can submit the cycle time estimation. Another function what we saw is under machine setup. Now, if I edit the setup, so you can see the preview of the setup, what you have defined, whether you are using any fixture. Along with the machine, you can see the preview before seeing the actual simulation. So it shows the machine, it shows the fixture, it shows the raw material and the part what you have defined. And apart from this, now in 2020, so now I can also, I can also set the absolute values with respect to the part position and also with respect to fixture position. So you can set these values inside the setup. So from the absolute value of the machine, the part position, what is the fixture position, and you can see the preview in the machine setup before going to the machine simulation. So these are some of the general enhancement what we have done inside 2019 SP1 and 2020. So let's move on to the presentation once again. So let's go ahead and see what are the new functions or new features which are available in 2.5D milling. So now the fixture protection and stock clearance optimization is available for 2D drilling. You can define the fixtures. So the links through the shortest distance will move the tool through the shortest distance, avoiding the updated stock, and it will also take care of fixture collision protection. You can also define the clearance value, how much you want to give the clearance value for the fixtures what you have defined. The same function is also available for pocket recognition, for pocket and pocket recognition. So fixture collision protection automatically adjusts the tool path to work around the fixture to protect them from cutting the tool. So you can also use this fixture collision protection for pocket milling and also for pocket recognition function. And after, let's assume we have put the top clamps, we have generated the program, and after that you want to move the clamps to a different position and you want to cut only the left out material. So you can have just copy paste the same strategy, and we have a function cut only the rest material. So then automatically it will machine only the left out stock after moving the clamp to a different position. And now 3D gouge protection is available inside the pocket and pocket recognition. So you can just select this 3D model gouge protection. So it will take care of gouge protection with respect to the target model what you have defined. Vertical arc ramping is available under profile. So this was a new ramping function which was introduced. So if you are doing a very small slot where you cannot use helical ramping and you would like to use a vertical arc, so you can always use this vertical arc ramp function inside profile milling. Another new function what we have introduced in 2.5D milling is multi-depth drilling. So when you are doing any deep hole drilling, and if you have any cross holes, so now with this multi-depth drilling, you have the full control of the drilling operation at every depth. So as it is very useful for people who are doing deep hole drilling and drilling through cross holes. So here inside the technology, you have, as a user, you have the full control. You can define different segments. So you can define where exactly you want to do the drilling operation, from what Z level to what Z level, and at each segments individually you can control the feed rate, RPM, and even the spindle direction, whether you want clockwise, counterclockwise. Generally when you're doing a very deep hole drilling where the LBD is more than 5 or 6, after completing the drilling operation while returning back, most the tooling supplier always suggests to take it in the counterclockwise direction and take the drill outside the part. So here with this multi-depth drilling, you have, as a user, you have the full control. At each segment, you can control whether you want to use the drilling cycle, what is the feed rate you want to use, what is the RPM, the coolant on, coolant off, each and every parameter you have the control. You have the full control, you can control them for at each and every segment. Another new function is updated stock based on the boundary inside face milling operation. So now when you go to face milling, you have two options. One is stock based boundary, another one is the target boundary. So by default, it is always set to stock based boundary. Depending on the stock condition, the boundary will be updated automatically. In this example, if you see the first image, it has done the face milling for the rectangular stock what is defined initially. Suppose if you have done the outside roughing, immediately when you generate the face milling technology, the boundary will be updated with respect to the updated stock condition, and it does face milling operation only within the stock boundary after the first outside roughing is done. And you can also select the levels inside the face milling, whether you want to use the top of the target or user defined or by top of stock. So depending upon the stock thickness, when you use by top of stock, upper level will be selected automatically. You don't have to switch on the stock model every time and select the top face. You have to just, in the milling levels, you have to just select by top of stock. Immediately it selects the upper level automatically depending on the stock definition. We can also now use multi-tools inside pocket milling operations. So when you're doing pocket operation, now it supports multi-tool function. So as a programmer, you can use several tools inside one operation. So you can define different tools. You can use a different tool for roughing, different tool for wall finish, different tool for floor paint finish, and individually you can control the parameter or operation, what you want to do, whether you want to do wall finish or floor finish, everything can be controlled individually. And also it's easily switched between each tool settings by clicking corresponding tool numbers in the flyout window. So you can individually select the tools and you can change them. You can tackle them individually, suppose if you used multi-tools. Again, in face milling operation, now direct only floor finish option is available. You can do floor finish directly. And now another new function is apart from doing inside the pocket, you can also do only floor finish. You can also do wall finish and floor finish together inside the same strategy. So this is available inside the technology, inside the finish parameters. Either you can do only floor finish or you can do wall and floor finish together. So these are all some of the new enhancements done under 2.5D pocket milling operation. And now inside chamfer recognition, now the direction you can control, whether you want climb or conventional. So you can choose, now you can opt to the conventional cutting direction when you're doing chamfer recognition. And another function, again, inside 2.5D milling pocket operation, now you have an open edge where you can define the negative offset. So this is very useful function. Again, many of our customers were asking about this. If you have an open edge and you don't want to go outside the edge of open edge, you want to keep some stock, you can always define a negative offset. So under geometry, you have that open edge offset value where you can give a negative value so that it offsets the open edge inside the pocket and it leaves the material only in the open edge area. This is another new function under 2.5D milling function. Again, another new function is under profile operations. Now lead in, lead out with the points is now available. It is fully associative. You can create a lead in, lead out points and it uses that point, and if you change this point, it synchronizes and update the toolpath if the location of these points are changed. So let's again go back to software and we will see these new functions, what is available in 2.5D milling. Let me open another part. So let's go to okay, I'll just open this part where we can see the fixture protection while doing drilling operation. Right, so let me open this part. Right, so now if I go to drilling operation, okay, now inside the technology, you have option here where you can define the fixture collision protection. So these are the 4 top clamps, what we have mounted here. So this has to be defined inside the setup. I will show that. So now I've enabled fixture collision protection. And if you are not sure whether these clamps are clamped in the same position exactly, so if you have any doubt, you want to give any clearance value, it is possible under fixture clearance value, you can set a value, okay, and you have to define these clamps inside the setup. You see the preview, so you can see it is defined inside the setup. These are the 4 top clamps. And when I generate the drilling operation, and let's go to simulation, so it will take care of this clamps protection automatically. So right, so fixture protection can be enabled inside drilling operation. The same function is also available inside pocket. Let's go ahead and see how we can handle that in pocket milling and how to do the rest material inside pocket. I just open the pocket. Right, so now again, let's go ahead and see this fixture protection inside pocket milling. So now if I go to setup, I have defined these top 4 clamps in my setup. So these are the 4 clamps, right? So I've defined them as a fixture. So now I'll go to pocket milling. Again, pocket milling geometry. Just pick, this is using smart face. This is my first pocket, second pocket, and third pocket. Just pick the 3 contours automatically. And I'd like to keep 0 stock. Let's go to tools. Select a tool from the tool library and use 10 diameter angle. Come to levels, just taken the level 5 millimeter, it's fine. I would like to keep 0.3 stock in the wall, floor 0. If it is an open pocket, I would like to approach from outside. If it is a closed pocket, I would like to use helical ramping. And now inside technology, okay, so we have set everything. I'll come to geometry, and then now I'll say fixture collision protection. So I'll switch on this fixture collision protection, and again you have this fixture clearance value. If you're not sure where exactly you have put these top clamps, you can always give a value, clearance value. I have put 3 millimeter, save and hit on save and calculate button. Right, so it's done the calculation. Let's go ahead and see the simulation, how it has done. Let's go to simulate, solid verify. So these are the 4 clamps. So now I would like to run the simulation. So it has taken into consideration all the 4 top clamps what we have defined as fixture, and it has also left 3 millimeter allowance what we have defined inside the fixture protection. So let's exit. So now I would like to move these clamps to a different location, and I would like to cut only the rest material. I just say copy the same toolpath, I'll say paste, and now I'll just go to SolidWorks, and now physically let's assume we have moved these clamps. On the 4 clamps, I would like to hide them. Okay, and now I'd like to switch on. These are the 2 more clamps where we have changed the position. So these are the 2 clamps. Now I would like to introduce a new setup before this operation. Okay, new setup. And now in this setup, now I would like to define new fixture. So these are the 2 fixtures what you're currently using. I'll just set up this, and let's just cross check the preview ones, see the machine preview setup. So these are the 2 top clamps, perfect. I'll just say accept. Let's go to the strategy now. Now I would like to remove only the left out material. Now I'll remove this fixture collision protection, and I'll just click on cut only the rest material. Let's save and calculate. Hit on save and calculate. So now what it has done, it has machined exactly the areas where the previous strategy has left stock because of the fixture collision protection. So now if you see, it is showing the new clamps, and these are the areas where it has left the stock. Let's run the simulation. So it is machining exactly, it is cutting only the left out material. So inside pocket milling, we can also define the fixture protection, and also after removing the fixture, if you want to cut only the rest material, you can also do that. It is available under pocket milling. Right, so next let's go to the next function, that is multi depth drilling. Right, so let's open another part, multi-depth drilling. Right, so if you look at this part, okay, here, let's say, like to assume we would like to do drilling these 3 holes from the top setting. But if you see the part, if I go to dynamic section, we have, let me show the section like this. We have 2 circular pockets or the bores which are already done in another setup. So there is a cutout in the middle in these 2 areas, and actual drilling or the operation has to be done from only from top to this depth. Then there is a open out, and then again there is a drilling operation to be performed, and again there is a open, and then again we have to perform drilling operation. So how to handle that? Now with this multi-depth drilling, now if I go to multi-depth drilling, so inside multi-depth drilling, you have to just pick the positions. I've selected all these 3 holes from the top. And now if I come to technology, here you have different segments. So as I mentioned, as a user, you have full control. You can control each and every segment, each and every level. Now, if you see the first segment, it is from +2 millimeter to -33 millimeter. It is doing drilling operation. What is that? If you go to evaluate and measure this depth, I go to evaluate and measure. So this is the depth 30 millimeter, the first drilling depth. So it is defined in the segment. It is starting from +2 millimeter. It is going up to -33. We have given 3 millimeter more because of the cone angle, which is there in the drill. So here we are doing drilling from -33 to -70. So it is going with a different feed rate of 1000, and it does directly G01. It goes, I don't want to do any drilling cycle, no pecking cycle. Whereas if I click here on the segment, you can see here I'm using the pecking cycle. Every time I'm going 1 millimeter depth, I'm doing pecking cycle. When I go to segment 3, I'm not using any drilling cycle. It directly plunges in G01. It goes to -70. Again, from -70 to -83. If you see this next depth, from -70 to -83, again, I've used the pecking cycle. So it does pecking. So you can give a different feed rate because my depth is now more. The feed rate has been reduced to 300. Okay, from initial depth, we've used 600. Now, since the depth has increased, that I've reduced the feed rate. So like this, you can define different segments. You have full control on each and every segment. You can control the feed rate. You can control whether you want the drilling cycle or you want, if there is a cross hole, you can directly enter in G01 with higher feed rate. Everything can be defined here individually. As a user, you have the full control whether you want the dwell, we don't want the dwell. And while coming back from the bottommost level back to the clearance level, it is set with different feed rate, 1000 and 3500 RPM, and even the spin direction we have changed to counterclockwise. So now if I see the simulation, let's go to simulation. Let me see the simulation. Let's run the simulation quickly. So now it is doing pecking cycle. Once it reaches 33 millimeter depth, you can see here after 33 millimeter, directly it goes to the next segment and then again doing drilling. So let's stop this. Let's go to Solid Verify. If you want to see in Solid Verify again. So now if I run the simulation, you'll not be able to see the simulation. Actually, inside SolidCAM, Solid Verify, you have a setting where you can set where exactly you want to see the simulation. You can set your interest of region. As my interest of region is at Y0. So it makes the section, keep this updated stock ready for you to see the simulation. Now I will run the Solid Verify. So now it is doing pecking cycle slowly with 1 mm pecking. It is doing drilling pecking cycle from 33 to 73. It is going G01 again doing pecking. Once it reaches 33 millimeter, it goes with a different feed rate in G01 to -73, again pecking, and again it is doing pecking. So as a user, now you have the full control with this multi-depth drilling function. Right, so fair enough, let me stop this. So let's close this. Let's go ahead and see another new functions what we have in 2.5D milling under face milling operation. Use this part. Right, so here let me suppress the first operation. So now if you see the stock definition, what we have defined, it's just a rectangular stock. So now if I do the face milling operation, so as I told, we have two options. One is part-based boundary and second one is stock-based boundary. So since I'm using stock-based boundary, it has taken the updated stock boundary, and when I calculate, so it has done the roughing with respect to the stock boundary. So suppose now let's assume we have done outside roughing. Let me unsuppress this. So I've done outside roughing. Okay, let me run the simulation quickly. Solid verify. So this is the outside roughing I've done using iMachining 2D. Right, so now again I'll go back to my face milling strategy. So now it has automatically updated the stock boundary. So now let us say save and calculate. It's done. Now it is doing face milling only for the updated stock boundary. So now if I go to solid verify, so it will run only within this boundary. So this will take care of updated stock boundary automatically inside face milling operation. Right, so let's go ahead and see the next function, that is multi-tool support inside pocket milling. Let me open next part. Right, so now inside 2.5D pocket milling strategy, you can use multiple tools. You can define different tools for roughing operation, different tool for finishing operation. So now if I go to SolidCAM operation, 2.5D milling pocket. So here, just pull down, you have this multi-tool option. So I'll use the geometry. So let's go ahead and pick this closed pocket. I've just picked the geometry using smart face, just selected the boundary. Now I'll go to tool. Now it will allow you to use multiple tools for the same strategy. Okay, right, so let's use 20 diameter end mill for roughing. I'll go to levels. Let's use 2 millimeter equal step down. I like to do roughing by keeping 0.3 wall offset and 0.3 floor offset. Okay, 50% step over, everything remains same. Okay, now again I'll come back to tools. Now I'll select the second tool. Again, it loads the tool library what we have created. Let me use another end mill. I would like to use 10 diameter end mill. And now I would like to do the wall finish and floor finish operations. So tool number 2 is 10 diameter end mill. Now I would like to do wall finish and also floor finish. Now if I come to technology, you can see the wall finish and floor finish is grayed out. It has taken wall finish and floor finish. If you want, you can also select here wall finish and floor finish. Let's save and calculate. Right, so perfect, it has already done. It has created two different strategies, one for roughing and one for wall finish and floor finish. The first operation is with 16 diameter tool, 20 diameter end mill. It has done the roughing of the pocket, and it has also created a separate strategy in the CAM tree where it has used a 10 diameter end mill and it has done wall finish and floor finish automatically. So you can use multiple tools inside pocket milling technology. So inside the CAM tree, it creates two different strategies, separate program for roughing and separate program for wall finish and floor finish. Like this, you can use multiple tools and you can generate the tool path inside pocket milling. Another function is open edge function. Again, let me copy the same instead of generating. Let me open this strategy itself instead of generating a new function, pocket milling. So if I click on geometry, this is the face. Okay, here you have an open edge. Suppose you want to give a negative offset for this geometry. Now you have an option here, open edge negative offset. Here you can give a value. Let's say I want a 10 millimeter stock for this open edge. I don't want to approach from outside. I don't want to go outside. I would like to keep stock for this open edge and give a negative offset for open edge here. Okay, I can also define this 3D model gouge check protection. It picks the target automatically if you have an undercut. So right now I'm not using that. I'm just using this open edge value. Just say save and calculate. Increase the value so that you will get more clarity. So what it has done now, so open edge has been offsetted. So if I go to top view, the tool path is now about 15 millimeter inside this open edge. So now it will allow you to define a negative offset if you have any open edge. So it is available and under geometry. So we have this open edge option where you can give a negative offset value. Right, so fair enough, these are some of the enhancements which are done under 2.5D milling. So just to summarize what all we have seen fixture protection inside drilling, fixture protection for pocket milling, and also you can move the fixtures and you can cut only the rest material. Then you have multi-depth drilling function. Updated stock boundary will be automatically calculated for face milling operation. And inside the pocket milling technology, you can use multiple tools. You can use any number of tools and it automatically creates different strategies in the CAM tree. And also now you can also define a negative offset for open edge. So these are all some of the new enhancements which are done under 2.5D milling module. So let's go ahead and see the presentation again. We will see what we have done in iMachining. Let me go back to my presentation. Right, so in iMachining, now again in iMachining 2D and 3D, we have support for multi-tools. So like what we saw in Pocket, the same function is also available for iMachining 2D technology and also for iMachining 3D technology. You can define any number of tools. So you can do roughing, wall finish, floor finish as per the tool you can define, and you have the control for each and every tool. The same function is also available inside iMachining 3D. You can use multiple tools. You can do roughing and rest roughing even in iMachining 3D. And another very major enhancement or changes what we have done in iMachining 2D is we have introduced feature recognition functions. So earlier for all iMachining 2D function, we used to select the contours manually. Now with these feature recognition functions, it makes very simple for the user. So you have three different kinds of feature recognition functions. One is feature recognition by faces. Then we have feature recognition by chains. Then we have outer feature recognition, and then the old option chains without feature recognition. So these are the four options which are available inside iMachining 2D. So earlier we used to see only the contour selection. Now when you go to iMachining 2D, so automatically you will get these four options: feature recognitions by faces, chain, and outside feature recognition, and chains without feature recognition. So when you use feature recognition by faces, you have to just pick the face using the smart face technology. The moment you pick the face, iMachining will pick the boundary automatically. It also highlights the machining region and it will be displayed in a different color. It also displays the upper level and lower level automatically. As a user, you are very clear, you know the regions where exactly it is going to generate the toolpath. what is the upper level it has selected and the lower level it has selected. Everything is very clear for the user. This is feature recognition by faces. So the second option what we have is feature recognition by chains. So when you are doing any through pockets, if you are doing side milling profiles, where you will pick only the chains, then again automatically it picks the chain, it selects the upper level, selects the lower level. It also again marks the machining zone in a different color, it highlights that, so that as a user again you know where exactly it is going to generate the toolpath. The third function is outside feature recognition. Suppose if you want to do outside roughing, earlier we used to define the stock boundary, we used to select the target boundary, and then we used to generate the toolpath. Now with this outside feature recognition, so it picks the stock boundary, it picks the target boundary, machines outside roughing automatically. Again here it highlights the upper level, it detects the upper level and the lower level automatically. It shows the preview of a machining zone in a different color. So it generates outside roughing automatically. So what the last function what we have is chains without feature recognition. Here again you can use the standard chaining method which is available inside SolidCAM. So you can use the chain options and you can create 2D chains and you can use to generate the toolpath. So if you look at overall what we have done is we have done complete automation inside iMachining 2D using these feature recognition functions. As a user, you will have very less functions to create or very less options to create the toolpath. You have to just pick the face with feature recognition by face, or you have to pick just the outside roughing, it automatically generates the toolpath. In addition to this feature recognition function, now you can also extend the toolpath with respect to the stock protection. You can also have extension options with tangential extension, and also we have fixture collision protection inside iMachining 2D. So this is if you have a semi-open pocket, now you have an option where whether you want to extend in a tangential manner, tangential extension you want, or to the closest point. You have both the option where if you want to avoid to machine the complete area, you can give the closest point, it machines only like the right side picture. So another new function which is available inside iMachining 2D is where we can control the helical ramping radius. If you want to machine a very small slot where you cannot fit the helical ramping, the diameter, what the default diameter used to take, then you can always go to SolidCAM settings. Inside the part setting, you have this minimum helical ramping radius. You can increase the ramp radius value, percentage value, so that it fits the helical ramping inside the small channel where we would like to open that particular channel using ramping function. Another very important function, what we have introduced in iMachining 2D, now you can introduce a 2D floor fillet. If you want to, suppose if you want to use a flattened mill and you would like to introduce a fillet at the bottom without modifying the 3D model, if you have a sharp corner in the 3D model or in the target model, if you would like to introduce a fillet, now this particular function is directly available under geometry function. You can introduce the fillet, you can define the radius value and what is the scallop you would like to give for this fillet generation. Using a flattened mill cutter, you can generate the bottom flow inside iMachining 2D strategy. And now we started supporting STL holders, collision protection inside iMachining 3D. You can use an STL holder, and also you can define these STL holders for collision protection inside iMachining 3D. Now it is possible. You can use these STL holders and you can check for collision protection. Another new function which is introduced in iMachining 2D is 3D positioning. Okay, this is the new function which is available under again link. You can use this 3D positioning, where if you have a pocket like this where you can find a lot of traction when it comes to the corner. So it goes to the clearance plane, then get repositioned, then machines this corner. If you use 3D positioning on, if you use this particular function, you will not find any retraction. All the linking will happen within the same level. You will not find any retraction in the toolpath generation. Another new function very useful for people is for having CNC machines with variable controller is now you can define user-defined arc fitting tolerance. So with this function is again available under miscellaneous parameters. Now you have this option where you can fit arc, you can enable this particular function, you can define your own tolerance parameter. So by changing this parameter, tolerance parameter, the program length will be reduced. So you can modify the default tolerance value with the preferred large tolerance value, and this can be useful for CNC machines with limited memory on the machines. So the program length will be reduced. So it decreases the length of G code and decreases the accuracy of engagement angle, so that the program size will become smaller, and you can use this function whether if you have any CNC machines where you have this limitation on the CNC controller memory. Now you can change this fit arc tolerance parameter inside miscellaneous parameter, so that your program G code length will be reduced. So this is what it does when you have a small curve fitting with the tolerance, and this is a large arc fitting tolerance. So you can see the number of points it has taken. So the segments highlighted in blue represents the toolpath of the arc here. So this is the left-hand side one is a small arc fitting tolerance, and the right side one is large arc fitting tolerance. So the number of points will be reduced, your G code length will be reduced, and you can use this G code for older machines where you have limitations on the CNC controller memory. Another new function again which is available inside iMachining 3D is now as a user you can by default you can set your maximum cutting angle. So if you are cutting softer material, you can limit this maximum cutting angle to 80 degree. If you are cutting harder material, you can set this maximum cutting angle to 40 degree or 45 degree, whatever maximum cutting angle is recommended by the cutting tool manufacturer. You can set that in this parameter, maximum cutting angle parameter. So this is available only inside iMachining 3D. So these are all some of the enhancements what we have done in iMachining. Let's go back to software and we'll see the same thing. Let me open a part. Right, so what are the functions we saw inside iMachining in the presentation? The first thing is when I go to iMachining 2D, now let's see the multi-tool next. Now if I select iRough, now if I click on geometry, so you have this feature recognition mode functions. So you have feature recognition by faces, feature recognition by chains, outside feature recognition, and then chains without feature recognition. So for example, let's say now I would like to machine outside first, and then I would like to machine the other pockets. So now I would like to use the first function, that is feature recognition, outside feature recognition. So the moment I pick outside feature recognition, you can see all other functions are grayed out. You don't have to pick anything. Just go to tools, select the tool from the tool library. I would like to use a 20 diameter end mill. So the moment I pick the tool, you can see it is now highlighting the upper level plus 1 millimeter, the total depth minus 65, and it is also marking the machining zone in a different color, and it is also showing the preview where exactly it is going to do outside roughing. Right, so fair enough. As a user now you have a very clear idea what is the upper level, what is the lower level, and what is the region or the area where it is going to generate outside roughing. Level is done. I'll come to technology. That's it. I'll just say save and calculate. So I have not done anything. I have not picked the stock boundary. I have not picked the target boundary. I have not selected the upper level. I have not selected the lower level. Nothing. I just selected feature recognition by outside roughing. It's done. Right, so let's go ahead and see the other functions. Again, I'll go to iMachining 2D. So now let's go to, again, roughing, geometry. Now we have feature recognition by faces. So now I'll just click on this face here. I'll pick face 1. So this is phase 1 and phase 2. So phase 1 and phase 2. These are the two phases. So I would like to use feature recognition by faces. Just go to tool again, select the same tool. So I'll pick same 20 diameter end mill. Select. So now if I come back now again, so it has marked the edges automatically. It marks the open edges. It has picked the upper level. It is highlighting the lower level. It is showing the machining zone or the region in a different color. It is showing the preview. Right. Fair enough. I'll come to levels. Okay. It is taken the level 6. Just hit on save and calculate. Right. So now what it has done, it has machined both the pockets. So now if I go to simulation, solid verify, let me run this simulation. So it has done both the pockets. So this is feature recognition by faces. So the third function, let me copy paste the same strategy, is by boundary. So let me edit this. Let's go back to geometry again. Now we have the third option by chains, feature recognition by chains. So here you can use any chain. I would like to use, okay, this particular chain, contour 5. And select again. The moment I pick the tool, it is highlighting the region. It has taken the upper level. It is showing the depth automatically. Just pick, go to the technology wizard, level 6, save and calculate. So you can see I'm not doing anything. Everything is completely automated. So for example, I would like to, let's say I would like to change the sequence. Now I would like to do this first roughing of this area first, and then I would like to do the pocketing. I'll just drag and drop this strategy below this. Okay, let me update the first strategy because it also considers the updated stock inside the technology. I'll just say save and calculate. This is my first level. Okay, is done. So I've changed the sequence. Now I've done the first level. Now if I go to the second strategy, I'll just say edit. You can see what it has done now. So it will consider the updated stock automatically. Let me hide this. So I've not done anything. It has taken the in process stock automatically. The upper level has been changed to minus 14.7 because in this particular roughing I've kept 0.3 floor offset. So it is not going to minus 15, starting from minus 14.7 and going up to minus 40 mm. So even if you change the sequence, the iMachining will recognize the updated stock condition automatically and it will take care of updated stock condition. Now I just hit on save and calculate button. So like this, you have done complete automation inside iMachining 2D. So you can use these feature recognition functions to generate the toolpath, and also you can use drag and drop template for also generating iMachining toolpath. Another function is support for multi-tools. I can go to iMachining 2D. Right. So now you can use multi-tools. Okay. By default, it always set to multi-tools. I'll come to geometry, feature recognition by phase. Let me select only one phase, this particular phase. Right now, I'll come to tools. Okay. First, roughing, I would like to use bigger diameter tool. Let's say 20 diameter end mill. I would like to use. Right, so I'll come to levels. Okay, technology wizard, level 6, and I would like to keep 0.3 wall offset, 0.3 floor offset, everything. kept same. I'll come back to my tool library. Now I'll select the second tool. Now I would like to use a different tool, 10 diameter end mill. Select, sorry, that is because exit this particular 10 diameter tool is used for a different material. Let me suppress this and also come back to the tool library. So I'll pick this 10 diameter end mill. If I come to iData, so here it is using a different tool. Let me synchronize that and exit. Now I'll come back to iMachining again. Right, so let's go to multi-tools, geometry, face. I just pick, this is my face. I'll come to tool, select the tool. The first roughing, I would like to use 20 diameter end mill. Pick the tool. Again, it is already selected. The boundary, it is highlighting the zone. I'll come to technology. I would like to keep 0.3 wall offset, 0.3 floor offset. Thing is set. Again, I'll come back to tool. Now I would like to use a different tool for finishing. So now I would like to use 10 diameter or 12 diameter end mill. 10 diameter end mill. I just select. So now with this tool, now you will get an option whether you want to finish wall or floor. Now I would like to finish wall. Okay, I just save and say exit. So automatically it has created both the strategies. I just click on calculate, hit on calculate button. So when you're using multiple tools, so it creates two different strategies inside the CAM tree. The first one is roughing with 20 diameter end mill. The second one is wall finish with 10 diameter end mill. Let's go ahead and see the simulation quickly. So solid verify. This is the target and the fixture. So it is doing roughing, and then now it is doing finishing with 10 diameter. So you have an option now. You can use multiple tools inside iMachining 2D and also inside iMachining 3D. So it creates two different strategies automatically in the CAM tree. Okay, fine. And another function what we taught is about the arc fitting tolerance, which is available under a miscellaneous function. So if I come to miscellaneous parameter, now if you have machines with old controller where you have the limitation of CNC memory. So if you click on miscellaneous parameter, you have this fit arcs and you have this tolerance option here. So you can change this tolerance. So if you increase the tolerance, your program size will be reduced, G-code length will be reduced, and you can use these programs on machines where you have CNC machines with a memory limitation issue. So this is available under miscellaneous parameter. And also, when you go to iMachining 3D, another function, what we saw is, let me just show that function. It's just a parameter instead of generating the tool, but now you have this, if I come to, sorry, selected tool. Right, so come to technology wizard. You have an option where you can set your maximum cutting angle can be set. So you can set your maximum cutting angle so that while generating the tool path, sorry, the technology. So you can set your maximum angle so that it will consider that how much, depending on the material what you are cutting, whether you want to cut soft material or harder material. So you can override this particular parameter. You can set your default value, the angle, maximum cutting angle will be considered by looking at this particular parameter. So this is available for inside iMachining 3D. So you can set maximum cutting angle. So these are some of the major enhancements we have done in iMachining 2D and 3D. So iMachining 2D is completely automated. You can use all these feature recognition functions. There's no need to pick the boundaries, select the upper level, lower level. Everything happens automatically by using these feature recognition functions. Right, let's go ahead and see the other enhancements what we have done. Go back to my presentation. Another major enhancement what we have done is we have introduced a new roughing engine. So we have introduced Turbo 3D HSR and Turbo 3D HSM. This is a new roughing toolpath engine built on 264-bit. It supports multiple core. With this new Turbo 3D HSR, you have ability to define multiple surface offset. You can define different set of surfaces and you can define different offset for them, or especially for the people who are into die and mold segment where they want to define multiple offsets. You have option to define multiple surface offsets inside Turbo HSR and HSM. Inside Turbo HSR, you have hatch, contour, and rest roughing. Model stock model definition, including undercut stock, is available. You can check collision with respect to fixture. You can define the fixture by 3D model or by set of surface, or you can use a 2D sketch. You can define the boundary and you can define it as a fixture. So it will take care of fixture collision automatically. You can also use a pre-drilled hole definition for entry of tool. Suppose if you are using a non-center cutting tool, you would like to do a pre-drilling operation and you want to plunge the tool always inside the pre-drilled hole. Now that is directly available. You can use that pre-drilled hole definition for entry of your tool. It also supports dynamic hole to collision checking while generating the tool path. And you can also control in the feed control zone. You have an option where you can define variable feed rate. You can also define variable depth of cuts, arc fitting for reduction in G codes. So these are all some of the highlights of Turbo 3D HSR and HSM. In Turbo 3D HSR, you have, as I mentioned, you have three different strategies. You can do hatch roughing, turbo hatch roughing, and turbo contour roughing, and turbo rest roughing. Then for finishing, you have as I mentioned, this particular Turbo 3D HSR, it's built on 64-bit engine. It also supports multiple cores. So your speed of calculation increases as the number of core increases. If you are generating the same toolpath on a system where you have 6 cores or there are 8 cores, the speed of calculation will vary depending on number of cores. It takes into consideration of utilization of 100% utilization of all the cores available in your system. And it also does the toolpath caching. Suppose when you have done the calculation and you would like to change any parameter. Suppose you want to reduce your depth of cut or step over. When you do the changes, when you do recalculation, the recalculation happens at lightning speed because the toolpath caching is already done. It will save all those in the memory. When you do recalculation, the recalculation will be done at lightning speed. So as I mentioned in the first slide, now you have inside the Turbo 3D HSR, you have option where you can define multiple surface offset, especially as I told for people who are into die mold. Now you can pick the entire target, you can define a global offset. Suppose for a particular set of surfaces, you want to give a different offset, you can always pick those surfaces and you can define a different offset, either the global offset or you can define in radial offset and axial offset, you can define different offsets. This will be very useful for people, as I mentioned, who are doing the die mold. You would like to keep a different offset for parting area and you would like to keep a different offset for the component area. Now it is very easy. You can pick different set of surfaces and define different offset and generate the toolpath. Inside Turbo 3D HSR, as I already told you, have 3 strategies. You can do hatch, contour, and rest roughing. These are the 3 different machining patterns which are available. Rest roughing, inside Turbo 3D HSR rest roughing. So inside rest roughing, you have both the options. You can generate rest roughing strategy using updated stock condition, or you can use the previous tool reference. So either you can use the reference tool or you can use you can always respect the updated stock condition. Both the options are available, or you can use updated stock and previous tool previous tool reference together and generate rest roughing. So arc fitting in the rapid moves provides smooth transition between the passes. So this is very useful. The smooth transition of the tool movement happens on the machine by using this arc fitting option inside rapid movements. And now you can also define a local stock definition. You can pick a set of surfaces and you can create a local stock inside Turbo HSR. And also we have a very nice function where if you have an undercut, so you can use this function, you can remove unnecessary passes. When you tick this function, stock has undercuts, it removes those passes wherever it finds an undercut, and it reduces the tool path length and time. Fixture collision protection is also available inside Turbo 3D HSR. So as I already told, you can define the fixtures. There are three different options. Either you can define the fixture by using a 3D model, or you can select the surfaces, or you can define a 2D boundary and can be defined that as a fixture. Suppose you want to use top clamps or something, you can use the 3D model and define it as a fixture, or you can create a 2D boundary and you can mark the curves definition as the fixture zone so that it will take care of fixture protection while generating the tool path. So you can also, as I told, you can also do a drilling operation, and you can use this pre-drilled point for entry of the tool while generating the roughing strategy. This is, as I told, very useful when you are using a tool which is having non-center cutting tool. If you are using a non-center cutting tool, you cannot do ramping. You can always use this drilling function, and you can use this pre-drilling hole for entry. Every time the tool goes and plunges in the pre-drilled hole and then do the roughing strategy. We also have option to control the feed rate. Under feed control, you have adaptive feed rate where you can control your feed rate. This adaptive feed rate function will allow for constant cutting condition, and it is very useful feature for roughing that increases the tool life, especially when you're using inserted type tools. When it comes to corner, if you want to reduce your feed rate, so you can use this adaptive feed rate function and you can reduce the feed rate. So the feed rate will be automatically drops to the percentage whatever value we have set in the adaptive feed rate value, and then you can continue with the G01 feed rate what you have defined. It also supports dynamic holder collision inside Turbo 3D HSR. You can define the holder and it will take care of holder collision checking automatically with respect to the target, or you can also check with the machine surfaces, both the options. So it will take care of dynamic holder collision while generating the tool, especially when you want to use a shorter tool and to machine the maximum possible depth. You can define this dynamic holder collision that will be taken care inside Turbo HSR automatically. And when it comes to finishing, we have different kinds of strategies. And inside Turbo 3D HSM, you have constant Z level machining. So you can use constant Z level toolpath calculation with adaptive step down, and also it detects the flat area automatically. You have one way, you have zigzag and spiral strategies which are available inside constant Z machining. We also have linear machining inside Turbo 3D HSM. So with the linear machining, you can use a constant step over method or scallop method or adaptive step over method and generate the toolpath for all the shallow areas. And another very unique function which is available inside Turbo 3D HSM is we have a function called optimum machining angle in XY. So the moment you pick this function, so the Turbo HSM will take care of the most optimum angle to generate the toolpath in linear strategy. So we also have constant step over machining strategy inside Turbo 3D HSM. So we can also do pencil milling inside Turbo 3D HSM, where the pencil milling offers effective toolpath generation for finishing only all the corners. You can either do with single pass or with multiple passes. So you can also do constant rest finish. You can, with this strategy, you can use any combination of tools. You can use a ball nose tool, you can use a bull nose tool or flattened mill, and you can do constant Z rest finish inside Turbo 3D HSM. We also have constant step over rest finish. Here again, in this strategy, you can use any combination of tool. You can use a ball nose tool, bull nose tool, or flattened mill, and can be generated. Okay, as I mentioned, you can use this optimum angle, and it can be the software automatically generates the toolpath taking into consideration the most optimum angle. You can also control the start point where exactly you want to start and the toolpath generation. The ramping option, you can always set your preferred ramping function. If it is not possible, you can also set the sequence of priority. If helical ramping is not possible, what has to be the next option you can use, whether you can use zigzag or linear or profile. All these ramping functions can be set as a default priority sequence. So it will pick the ramping options looking at that, the sequence of priority what you have defined. This is another function for more accurate sharp corner inside 3D HSM toolpath. So you will get a very neat sharp corner. Instead of sharp corner, you will get a small fillet. So a fine radius is added to prevent the wall damage. So this is a new function inside 3D HSM. And undercut milling. Again, this is a new function inside Turbo HSM. You can do undercut milling using constant Z level machining. So with this function, you can generate the gouge-free toolpath. It supports two different kinds of tools. You can use a slot and mill and the lollipop cutter. So it will take care of automatic collision control with the shank and the holder and generate the toolpath automatically for undercut areas. So now you also have a feed control zone inside 3D HSM. Like HSS, you can also control your own feed control zone. You can control your feed rate. You can define your own feed rates. Right, so let's quickly go ahead and generate some of the toolpath and see how Turbo HSM can be used. Let me open the part. Right, so this is the part I'm going to use for generating turbo strategies. So look at this part. This is a die, forging die of size 300 millimeter by 176 by 102.75 millimeter. So you can always create, you can right click on operation, you can go to add milling, you have Turbo 3D HSR and Turbo 3D HSM. So instead of generating the strategies, I've already created some templates. I would like to use the templates and generate the toolpath quickly so that we can, right? I'll just use this roughing template, just drag and drop it on the cam tree. So Mac 1, position 1, perfect. So as I mentioned, when it comes to roughing, we have two different strategies, hatch, turbo roughing with hatch pattern and contour. So I'd like to use contour, Turbo HSR contour. Geometry, my geometry is the target. This is my target. This is the target model. I've selected the target model. Now here under offsets, now I've defined a global offset of 0.5. Now we have an option where you can define a different set of surfaces. For example, this and this, these are the two surfaces where you would like to keep a different offset. Now I say for these two surfaces, I would like to keep 0.3 stock. You can define that. So fixture definition can be defined here. Inside here, you have the option where you can define by faces or by curve, or you have a 3D model can be defined. You have this pre-drill hole option here. If you are using non-center cutting tool, you can do a drilling operation and you can use a pre-drill hole for entry. So right now I'm using center cutting tool. I'm using 25 or 2.5 bull nose, and I've selected dynamic holder checking option. So check with in process stock, and I've defined a clearance of 0.5 millimeter level. So more, if you see any turbo HSR roughing or turbo HSM strategies, you will find only few parameters. Most of the parameters are automated. It takes automatically, the level is set, it detects the plane highest level automatically, and under levels, distance is set to previous Z height. Not worried about that. Boundary is set automatically. I'll come to passes. So I'd like to use 0.8 millimeter step down and step over 50%. That's it. It has done everything. The ramping priority, everything is set. I'll just say save and click on save and calculate button. You see now the calculation speed. So this is a die size of 300 by 176. So it generates the roughing strategy, I think, with less than 50 seconds. So now it is just checking the stock. Yes, it's already started calculating. So it will take approximately close to 45 to 50 seconds to generate roughing for this particular time. So as I mentioned, it uses all the cores. So if the number of cores increases, the calculation speed also increases. It utilizes 100% utilization of all the cores will be done inside Turbo HSR. Yes, it is done. It has taken 1 minute, 34 seconds, 37 seconds. Right, it is calculated the roughing strategy. It is now generating the preview. Let's exit. So it has created the roughing with 25 or 2.5 bullnose. We have done the roughing. Again, let's go back to the template. Now I would like to do rest roughing. Okay. So before that, let's run the simulation so that you'll understand how it has done. Solid verify quickly and run the simulation. Right, this is the stock, and what it is doing now, it is doing helical ramping and using the contour strategy. Right, so let me stop. Let's go ahead and create rest roughing. I just again use another template, just drag and drop it on the cam tree. Mach 1 position 1. Okay, done. Accept. Let's go back to geometry now. Right now, I would like to use rest roughing, geometry. Okay, geometry is the target. I would like to keep same 0.5 stock. Tool, I'm using 12R.9 bullnose cutter. Levels is set to default, boundary is same. Here, instead of using reference tool, now I would like to use to respect the updated stock. I would like to use updated stock function. Tolerance is 0.1. I would like to detect only material which is more than 0.6 millimeter because I've kept 0.5 stock in the first roughing and tolerance is 0.1. So I would like to detect only the material which is having more than 0.6 millimeter. I come to passes 1 millimeter. Okay, 50%. Yes, step down. That's it. I'll not do anything. I'll say save. Yeah, I'll hit on save and calculate button. So now you can see it is already started calculating the updated stock material. So it is now calculating the updated stock. Once it does the calculation of updated stock, toolpath generation will take hardly 40 to 50 seconds for generation of toolpath. So after this rest roughing, we will just see the simulation and then we'll start generating the finishing strategies. Right, so it's almost done. Right, so it has calculated the updated stock now. Now it will generate the toolpath. The toolpath generation would take approximately 40 to 45 seconds. Yes, it's already started calculating. Yes, it is 65%. Yeah, just done the calculation. Took about 42 seconds to do the rest roughing. Now, if you see the toolpath, so it has done very neat toolpath. It has machined only the areas where the previous tool has not done. It is doing completely region wise. Now let's quickly go ahead and see the simulation. If I go to solid verify, update, sorry. So it is updating the stock condition after the first roughing. Just a second, it is updating the stock condition in the simulation mode. Right, so it's almost done. Okay, so this is how it looks after the first roughing. So now if I run the simulation, so you can see now how exactly, very precisely it has done the rest roughing, and it also generates the toolpath region wise, no air cutting, machines only in the areas where the previous tool has not entered, uses region by region, and machines the left out stock. Right, so let's run the simulation completely. Okay, so it has removed all the stock. Let's go ahead and do the comparison. I'll just check. So even after doing rest roughing with 12.9 bull nose, it has left a lot of stock in these areas. So you can always go ahead and introduce one more rest roughing. Let me introduce the one more rest roughing. So again, I'll go to second rest rough. I'll just drag and drop it the tree, Mac 1, position 1. Okay. Let's select the geometry. Geometry is my target, so I would like to keep the same stock using using the boundary definition same. I'd like to use the boundary, and now again here I would like to use updated stock condition, and I would like to detect stock of 0.6 since I've kept same 0.5 mm stock. My depth of cut I would like to use 0.5 millimeter, 25%. That's it. Rest everything it will take care, and just save and calculate. Again, it will take care of updated stock automatically, and then just generate the toolpath. Let me quickly create the finishing operations after this. Right, it is already done. It's taken care of updated stock. Now, maybe another 20 seconds, it will do the generation of the toolpath. Right, it is almost done. So let me complete this, and then let's move ahead with the other functions now quickly. So it has done 49%. Okay. Right, so just done the calculation using 8 ball nose cutter. Right, so took about 1 minute 26 seconds. It is now start 1 minute 30 seconds. Okay, so it has done the second rest rough. Okay, now if you see the toolpath, there's a generated toolpath only again in the left out area. Now let's quickly complete finishing. Again, I'm using Z level. I'll just drag and drop it, the same Mac position. Right, so you can see how quickly it generates the toolpath finishing strategies. Just take constant Z, and my machining surfaces are same. I'm going to use the same 8 ball nose, boundary remains same. Step over, I would like to use 0.25. My range angle 27 degrees to 90 degree. That's it. Rest everything it takes automatically. Right, I'll just I can use a cutting method zigzag, save and hit on save and calculate. So this finishing strategy now, it is not going to consider the stock definition. It will happen in maybe 10 to 12 seconds. It generates the finishing program. Right, so it is done. It took about 25 seconds to generate a constant Z level finishing strategy. Just complete this. Generating the preview. Done. So it has machined all Z level strategies automatically by picking 27 degrees to 90 degree. Let me complete the last one, linear finishing. I just again drag and drop Mac 1 position 1. Again, I'm just using the template which is already available. I would like to use the geometry as my target model. I like to use the same 8 ball nose cutter, boundary remains same, passes. I like to use same 0.25 and tolerance of 10 microns. Now I'll say use optimal angle in XY direction. Save and calculate. So this will again take another 20 seconds to generate the toolpath with linear strategy. Okay, it is already done. Let me just see this. It's showing the preview. Fine, fair enough. So now it has machined all the linear areas, and since we have used optimized angle, you can see this particular surface it is machining in a different angle. When it comes to this particular surface, it is machining in a different angle. It automatically uses the optimized angle and it generates. So this is how we can generate turbo strategies. So let's move ahead and we will see what are the other things quickly, because we are almost close to 2 hours. We have done few enhancements in HSS. In HSS, now you can see the progress bar. So when you calculate the toolpath, now you'll get a progress bar where it shows what exactly happening when you're generating the toolpath. And you can also now inside HSS and also for 5-axis milling operations, you can deactivating the options when you're using multi-passes or depth cuts and translate or rotate. Used to go inside again, switch off, and then again we used to come outside and then switch off. Then the check boxes now you can directly switch off outside the HSS strategies itself. And now inside HSS now we started supporting multiple boundaries. You can use multiple boundaries and you can trim the toolpath. You can restrict the toolpath using multiple boundaries even for HSS and simultaneous 5-axis milling. Even the toolpath extension, it happens automatically. Now the extension happens even region-wise inside HSS toolpath. Okay, let's quickly go ahead and see these changes. Let me close and open part. Right, let me open an HSS part. Right, so let me open the new part, HSS part, where you can see how to use multiple boundaries and what are the changes we have done. Open the part, right? Right. So now I would like to use this. I'll edit the strategy. Now, to change any parameter, let's say like go to 2 parameters and increase it to 0.4. Let me save. And when I click on save and calculate, now immediately it shows the progress bar. You can see the progress bar, what is happening, and then generates the toolpath. So now another function is now you can start using multiple boundaries. For example, now inside geometry, now let me remove this boundary, save and calculate. So again, it shows the progress bar. So you, as a user, you know what is happening exactly. And now you can see now I've generated the toolpath for the entire area. Now, if you want to use this boundary definition and you want to trim, now you can edit the toolpath. And inside HSS, now under geometry definition, you have option to define 2D boundary, and you can define any number of boundaries. So for example, now I'll pick, this is my boundary 1. Okay, this is boundary number 2. So I've selected both the boundaries. I'll say accept, and then projection direction is Z is perfect. I'll just hit on save and calculate. So it will consider these two boundaries, and toolpath will be trimmed only inside these boundaries. So now you can go ahead and define any number of boundaries inside HSS strategies. So it supports multiple boundaries. Right, so these are the two enhancements which is done in HSS. The last function, okay, I just take another 2 minutes. I'll just show the last function where that can be used. You have a separate simulation window now. If you want to see any simulation, so instead of seeing the simulation inside the solid verify environment, I can just right click to have a separate simulation window. So it opens, when you say simulate separately, it opens a separate window. You can see the simulation outside. You can keep running the simulation. So you can also keep working in the SolidWorks and SolidCAM environment, keep generating the toolpath. Here you can record, you can go see the preview, and also while running, you can also see when you're running the simulation. So you have the toolpath, you can stop the toolpath, you have the full control, you can pick any segment, you can place the tool, you can see the tool preview. So everything is possible. This simulator opens in a separate window, and you can keep seeing the simulation separately. You have a lot of options here. You can record this video, you can go back, see the simulation once again, and this can be minimized, and you can keep continuing generating the toolpath inside SolidCAM environment. So these are all the major enhancements what we have done. I think I have taken more than close to 2 hours. Thank you very much for your patience hearing. So I would like to hand over to Amod.
Thank you, Ashok. I have been already answering a lot of questions on the side, and I believe most of the questions are answered. In the event some of the questions are not answered, then I would request you to get in touch with us ASAP so that we can answer them via email. The recording of this webinar will be sent to you on your emails. So please look at the email 24 hours from now. You'll have this recording on your email. It will be a link to you on your email. You can watch the recording later on after you have completed it. Thank you very much for your patience and attending the webinar. And all of you, please take care and have a wonderful day. Thank you. Bye-bye.
Thank you. Bye-bye.